Thanks everybody, and welcome back. So we're going to take a quick look at how to use our NumWorks calculator to find a couple of items. The first one is, suppose we're given a velocity in the x direction and the velocity in the y direction of some parametric equations. And how we would go about finding the slope of the tangent line at specific points. And given that same scenario, how can we go about finding the x coordinate of the position? All right, so we are told that we have a value of dx dt, which is ln of t plus 1. We also know that dy dt is defined by arcsine of e to the negative t squared. And so we want to find the slope of our tangent line. So we're looking for what is the value of dy dx at the position 2, 5. Okay, so dy dx is defined as, we talked about this in an earlier video, that's going to be dy dt divided by dx dt. Okay, and then we're going to use the point in time where the coordinate's 2, 5, and that happens when our t parameter is equal to 1. So let's go ahead and jump into the NumWorks calculator to figure out this first question. All right, so I have our NumWorks calculator here, and so the first thing I'm going to do is I'm going to go into the grapher. Okay, and in grapher, well, I'm going to hit OK, and I'm going to go to the templates because this allows me to get our parametric template. So we've got some f of t function, which is defined by some x parametric equation, comma, the y parametric equation. So I'm going to hit OK, and here I'm going to go back, and instead I want my x parametric equation to be the ln of t plus 1. All right, so that was my x parametric. That represented dx dt. And then I'm going to go get that y parametric equation, which represents the velocity in the y direction. And so that one was arcsine of e raised to the negative t squared. And let me get rid of this, which was, they gave us an element of t already. And so now I hit OK, and it's saved my parametric pair here for the velocity. Okay, so now what I'm going to do is I'm going to go to the home screen and then go back to the calculation app. And in the calculation app, I want to take my dy dt, which I've stored in the y component there, and my dx dt, and I'm going to divide them. So I'm going to hit the vars key, and I'm going to go under function, and I'm going to grab the y component, that arcsine function. Okay, and I want to evaluate that when time was 1, divided by, I'm going to go vars, and this time I'm going to grab what's stored in the x component of my parametric, which represents the velocity in the x direction here, at time equals 1, and hit enter. And so this will give me the slope of the actual xy path that our object is on. Okay, so that's the answer to that first question. All right, so now let's go back to the question. And the second question that it's looking for is, it wants to know what the x coordinate of the position is at time t equals 3. Well, I know that if I take the integral of my velocity, okay, I get position. All right, so if I take the antiderivative of velocity, I'm going to get position. And so that's true whether I'm dealing with the parametrics or not parametrics. So if I take the integral of ln of t plus 1 dt. And I find that from time equals 1 to time equals 3. That gives me my change in position from 1 to 3. Now, I need to know where I started at time equals 1 in the x direction. So I'm going to add to that my x position at time 1 originally. And because of our first fundamental theorem of calculus, we know that this is going to be equivalent to my position at time 3. Okay, because position at time 3 is where did I start at time 1 and how much did I change by from 1 to 3. Okay, and so we know that the x coordinate at time 1 is a value of 2. This value right here in blue is a value of 2. So to find my position at 3, I need to take 2 and I need to add that to the integral from 1 to 3 of the x component of the velocity. All right, so that function right here. So let's use our NumWorks calculator to be able to do this super quickly and efficiently. All right, and it's nice because we already have the ln of t plus 1 function stored into our grapher. So I am going to first take my position at time 1, which I know to be a value of 2, and I'm going to add to that. Now I'm going to go into the toolbox and down to calculus. And I'm going to arrow down in our favorite menu on NumWorks, our calculus menu, and I'm going to grab the integral, okay? And I want to go from 1 to 3, and I'm going to go over to the dx. I'm going to go over to my little differential here, and I want to change the variable for my differential. I want to do this with respect to time. So I'm going to delete the x, and I am going to hit the x, n, t button 1, 2 times, and that will grab the t variable. If I hit it another time, it would grab my, my theta value. Now, for my integrand, I want to go grab what was stored in the x component for my velocity. And so I'm going to choose vars again, and I'm going to grab the x component here, that ln of t plus 1. So if I hit OK, that grabs the x component. Now I just want that as a function of t. So I hit my x, n, t, x, n, t. I hit the wrong button there. It will automatically pull up the variable t because I already chose the differential to be dt. If I hadn't done that first, I wouldn't have been able to select the t there. Now all I need to do is hit execute. And there we have it. So our x position at time 3 is 4.159. Thanks for watching. More tips and tricks on NumWorks and BC Calculus coming your way.